Welcome to Schrödinger's classes. Today we'll be learning about radial and angular probability. Now, before proceeding further, we need to see the relation between Cartesian coordinates and the polar coordinates. Z is r cos theta, y is r sin theta sin phi, x r sin theta cos phi. Let us see what we derive from this. Now, from a previous video on Schrödinger equation, we had derived the following equation. Over here, nabla square phi is nothing but d square psi by dx square plus d square psi plus d square psi by dz square. Now, we will be changing this equation into polar coordinates. Thus, nabla square phi becomes 1 by r square del by dr into r cube, or rather, let's not do this very fast, r square del psi by del r, this whole term plus 1 by r square sin square theta into del square psi by del phi square, and lastly 1 by r square sin square theta into del by del theta into sin theta del psi by del theta. The solution of this is of the form of psi equals to capital R into small r dot into psi into phi into small phi. Over here, RR is a function that depends on the distance from the nucleus, which in turn depends on the quantum numbers n and l. Now, the next term is a function of theta, which depends on the quantum numbers L and M. This equation may be written as RRNL into AML. This splits the wave function into two parts, which can be solved separately. The first one, let me change the color so that you can see this easily. RR is the radial function, which depends upon the quantum numbers n and l. And secondly, AML, which is nothing but the total angular wave function, which depends on the quantum numbers m and l. Okay, I'll write down for the previous one also, n and l. The radial function r has no physical meaning, but r square gives the probability of finding the electron in a small volume dv near the point at which r is measured. For a given value of small r, the number of small volumes is 4 pi square. Now, the angular function A depends on the directions and is independent, that is independent of distance from the nucleus. The angular function A does not give polar diagrams, but when we find A square, therefore A square is nothing but the probability of finding an electron, let us denote that by E, at a given direction, that is theta, and phi at any distance from the nucleus, and that will range from the nucleus to infinity. However, note that the polar diagrams do not give the total wave function, it only gives the angular parts. Thus, the total wave function, that is phi, which equals r into a, thus the probability, let's write probability of finding an electron simultaneously. Let us assume a distance, that is at r, which we have assumed, and in a given direction, that is theta comma phi, is psi square r theta phi. Now let us see what this will be equals to. Therefore, we can represent this as phi square. Notice this will look like a bit of the Schrödinger's equation, that is phi r theta phi, which is equals to r square r into a square theta phi.